Welcome back, everybody. Now we're going to start talking about, yes, OSPF. Why did Cisco decide that in their volume 1 they're going to put OSPF? I don't know. They talk about very basic things in OSPF, but inside the presentation is you need to understand that you're about to watch. That I'll leave you with. You need to understand the terminology, the abbreviations, the theories behind OSPF, and when would you use OSPF? Remember, OSPF is a link state routing protocol. Link state routing protocol. It's a very big protocol because it really has no limitations. And I explained that in the presentation, but just to give you a heads up, I guess, OSPF, that doesn't mean that because since the area 0 is the backbone area, that does not mean that you're just going to have 20 million routers inside area 0. You're just not going to do that, or in one area. That doesn't make sense. Okay, so there you need to limit the size of your area to a certain amount. You decide what is that limitation based on the type of connections that you have going out towards your branch offices or whatever, or buildings or what have you. You need to make sure that, if you're using OSPF, is because you're medium size or almost right there at the enterprise level. It's not a protocol to be used if you only have 100 routers, or less, 50. That's why you have EIGRP, which you can use. But I mean, if you only want to use Cisco equipment, but there's nothing wrong with that, then you have to use OSPF. Just remember, it's a very scalable protocol, but it takes a lot of processor overhead on the router. It does do a lot of math, a lot of calculations. So OSPF is a very big routing protocol. So we'll be talking about the concepts right now. Later on, we'll be going into single area configuration and something called designated router and backup designated router. And we'll talk about those when we get into it. But again, things have changed in the CCNA 200-301. And it's just interesting terminology, and using the new packet tracer, which if you are going to use the packet tracer, definitely please go to the Net Academy, sign up, download the new packet tracer, even go through the little labs that they make you go through, the little class. I think it's like an hour long or something like that, to use this packet tracer, because even the outputs are different. The outputs are different, and they're allowing you to use a couple more different commands they're using now that they've added on to this new certification. We've always known about it, but we've never had to, configure it and stuff like that. So you can actually now see, and you will see when we get into the configurations, that by changing certain things in there, like hellos and things like that, I don't want to get into it. I don't want spoiler alert, right? I want you guys to understand all that, and you'll see it in the configuration anyway. So keep in mind, this is OSPF concepts. It's theory. Sorry, you got to learn the terminology. You got to understand the routing protocol. And then later on in this section, we'll go on to configuring OSPF. See you inside. All right, everybody. OSPF. Now in the new CCNA 200-301, Volume 1, they want you to know about OSPF. All right. So basically, OSPF has no limitations. That's kind of a general statement. Meaning that where distance, because this is a link state routing protocol, where distance vector routing protocols, even EIGRP, which is advanced distance vector routing protocol, has a limitation on how many routers it can go through. The maximum number is 255. With OSPF is 15. Well, OSPF doesn't have that limitation. What you need to think about, and as we go through the different lectures and configurations of OSPF, you're going to see, okay, this is what I can build and all this other stuff. So what we're going to deal with is areas. And we'll talk about that in a second. All right, so because you can have over 4 billion plus areas in OSPF, is there a limitation in how many routers you can have in one area? Or do you want to have gigantic, area? So these are things that you need to keep in mind or be curious about when they say that OSPF has no limitations on routers as far as how many you can have. All right, because it is a link state routing protocol, and it does not summarize. So what does that mean to you? There is no auto summary command. You don't have to worry about that. It actually, because of its algorithm, the Dijkstra, okay, it will not summarize. It does its calculation, and it's called the SPF, shortest path first calculation, in order to calculate, who's where, and it has a pretty good overview of the entire topology. So you will need to input exactly, and when we start configuring OSPF, you'll see how you would do that, because here's where you need to know your wildcard masking, because you need to actually tell it what network it belongs to, and then put it in a wildcard mask. So it does not summarize automatically. If you wanted to summarize, it could, but it will not do it automatically. You do need to put in all the networks you're connected to, so it can then send updates, and that's in its own something you need to understand about OSPF, how it does these updates. And then it has the following tables. Yes, obviously every routing protocol, every router, every device creates a routing table, all right, or some sort of a table, right, like MAC address table, things of that nature. Layer 3 can create a routing table as well, layer 3 switch. All right, we have a neighbor table, tells us who's around us. A database, because OSPF also creates something in the configuration, which you'll see, has a process ID number, which is a number that's basically local to the router, and it maintains that link state database, okay, because it creates a tree of the entire database that it creates. So to keep track of that database, of that tree, it assigns that process ID number, so you have a database table also, and it also does topology table, all right, because OSPF does pay attention to its topology. Now, terms, ladies and gentlemen, terms. When it comes to OSPF, and specifically the 200-301, learn these terms. These are you just need to know them. LSDB, what in the world is that? Link State Database. As it says right there, this is the data structure held by an OSPF router for the purpose of storing topology data in the link state database. Right? We said that the process ID, right, is the number that keeps track, right, that we know. We wanted to look at it. All right, we can look at the database, show IP OSPF database. We can go ahead and look at that database, and we'll see the numbers. All right, we'll see what's going on our topology. SPF, I said that was your shortest path first algorithm, or the mathematical algorithm that it uses to analyze the link state database. Then we have our updates, okay? When OSPF, and we'll talk about the different stages that OSPF goes through to create neighbors, it must do link state updates, right? So what this has, and be careful, because these the two terms I'm going to describe, this one and the following one, are close, but look at the differences. The name of the OSPF packet that holds the detailed topology information, database, or the OSPF packet, okay? Because there's a small packet letting you know, hey, there's a change in the network, here's an update, okay? And it sends the update, because that's what OSPF is. It's based on triggered updates. If there's a change, it will only send that change through an LSU. All right. Then we have LSAs. Now, LSAs can be tricky. There are different types of LSAs depending on what type of router you are. Where you're a backbone router, as you can see there in the terminology, or you're an area border router, or you're an autonomous system border router, all right, that goes beyond that, you'll use different LSAs. And they go all the way to, I believe, 11 different LSAs. Now, for the CCNA, I don't think you need to know all those. But we'll be discussing those further when we configure, and we'll be looking at them when we configure OSPF. So LSAs are part of how OSPF uses it to create neighbors. It says it's the name of class, because there are classes 1, 2, 3, 4, 5, 6, 7, right? And each one has a different purpose, all right, for it, and you'll see what they mean as we configure. The name of the class of the OSPF data structures that holds the topology information. So area, first thing you need to understand that OSPF is based on areas. You create a process ID number, fine, it'll maintain the database, but then you create an area. If all the routers are in the same area, that is considered a single area OSPF. So any changes within that area will be via a link state update. It will be LSA1, link state advertisement of 1, all right, which is in the same network, all right, or an LSA2, all right, if you're summarizing things of that. We'll get into that, but this is where the LSAs come in. Are you within your same network? Are there different networks? Are you an area border router? Or now, if it's summarized, it becomes an LSA3, or is it an LSA4? Anything beyond an LSA5, it gets tricky, because OSPF is very picky, okay? And it doesn't like certain LSAs coming into its network if it's external, right? If it's external. But again, some of these LSAs beyond 5, that's more for CCNP. But again, I want to make sure that you have all the information that you need, at least have it in your arsenal, so you can understand it and know that, oh, okay, these are the LSAs that they're talking about when we're doing, let's say, single area or just multiple area OSPF, which comes in the area border router, meaning a router that has interfaces connected to at least 2 different OSPF areas, which we'll do, all right, where you have area 0, because area 0 is the backbone router, as it says there. Any router that has at least 1 interface connected to the backbone area. I think those definitions are a little bit whatever. The backbone router is the router that has its interfaces are in area 0, okay? Meaning this router is area 0. You can have 20, 30, 40, 50 routers in area 0, and then those routers connect to area 1, area 2, area 3, area 4, area 5, right? The other routers that it's connected to, all right? Those are area border routers. A router that it has its interface that is directly connected to area 0. Beyond that, then we're talking about autonomous system border routers, where you're going outside of, even not only the area, but you're going, let's say you have another protocol altogether, which in that case, you're talking about route redistribution, which is not talked about in volume 1 at all. The most you'll go is ABRs, which is just one router connected to different area border routers, okay? And always remember, everybody must come back to area 0, and then area 0 will disseminate the information to everybody else. Either you're directly connected to it, or you're doing something via virtual links. As we configure, you will see. All right, internal routers that have interfaces connected to only one area, making the other routers completely internal to that one area. Because one of the things is, if you had, let's say, one router, right? Think of a pyramid in your mind right now, okay? And when we configure, you'll see it. One router, and that one router is area 0. Now, that one router has 2 facilitated interfaces. It will connect to 2 other routers that they're also connected to area 0, but then those other 2 routers have a router underneath, that one is in area 1 and one is in area 2. So we really have, 1, 2, 3 routers going on one side, 1, 2, 3 routers going on the other side. The top of the pyramid is area 0. The middle routers that connect to directly connect to area 0. Those routers are connected to both area 0 and area 1 or area 2, right? Depending on which one you want to do. All right, there will still be considered inter-area routes, all right? And you'll see that. One of the last things that we'll be configuring, because OSPF does do a pretty cool job, or it does something very interesting. It's called a designator router and a backup designator router. And as it says there, designator router on a multi-access data link like LANs, meaning a broadcast domain, an OSPF router runs an election by the routers on that data link to perform special functions. Now, multi-access, broadcast domain. We're talking about Ethernet. So if there's serial, there is no election. If it's a serial link, it will not run any elections. I don't know. They don't talk about it in volume 1 that the labs so far I've been only with Ethernet. I haven't seen any serials as of late. But if you're having serial connections, there is no election. When it runs the election, it will be on Ethernet. And what does it base the election? Why does it run an election? Because there's a priority number, which is through 0 to 255. If you have a serial interface, the priority number will be 0. If it's Ethernet or gigabit or what have you, it's going to be 1. So you can change that. You can change that. But when we get to that particular lecture, that particular configuration, you will see how to do that. All right. And it says, okay, the one with the highest priority number, we'll call it that for now, okay, because I don't want to give too much information away right now, will actually be the designated router. There's many things in the election process, which I'm not mentioning at this moment, that takes into consideration who's going to be the designated router. But one router will be the designated router. At this point, let's say, hey, we're going to use priority numbers. So on the interfaces, so the priority number with the highest priority, that will, the highest priority number will be the DR, and the one with the lowest will be the BDR. So that means if the DR fails, the BDR will take over, and information. That's why information is sent. That's why OSPF uses multicast 224.0.0.5 and .6 to send to the DR and then to send to the BDR. All right, so both can have informations. And you'll see when we go through this type of topology that we'll create that, and it's not going to be this huge, humongous friggin' topology that people create 30 friggin' routers with redundant links from hell and you just try and understand DR and BDR. That makes no sense whatsoever. Okay, you understand? Remember, you're taking the test. The point is, highest number, lowest number, DR, BDR. Okay, serial, no election is ran because the priority number is 0. Cool, I understand that. And we'll see when it starts creating neighbors, when we do that configuration, that certain routers will be called drothers, designated router other, and they will stop at a certain stage of neighbor relationships, and which is the two-way state, and because all the information goes to the DR, right? And the DR disseminates everybody. Could you imagine? Picture this, which you will see it when we configure. Picture this: a switch. I don't care if it's 2 or 3, layer 2 or layer 3, it doesn't really friggin' matter. You have a layer 2 switch, we're in one broadcast domain, okay? And everybody's updating to everybody else. That's a mess, right? All the routers are updating to each other. I'm connected to this, I'm connected to that. So it's a web of different connections. So in order to keep it more organized, what it does is, hey, send all the information to the designated router, and he'll take care of disseminating the information to everybody else. Oh, okay, no problem. So I won't go through all the stages of becoming neighbors. I'll just go up to the two-way state where we exchange information, and then the rest of it, we'll let the DR handle it. That's why we have a DR and BDR. But once we get into the configuration of this, we'll get into more detail. Okay? Now, OSPF. This is the stages that it goes through. The very first thing, we only have 2 routers right here. Simple, 2 routers, okay? Right now they're in down. You may have IP addresses. When I say down state, I don't mean the physical links are down. No, they can be up. You can have an IP address, up, you look at show IP route, you'll see that they're connected. But the routing protocol, right, it's not configured yet. You haven't done anything. So once you configure the routing protocol, at first it's down. Okay, that's the down state. When it sends a hello, and this is very important because the hello advertisements that you see when you do show, what is it? I forget the command. We'll see when we do the configuration. I believe the show IP OSPF interface, and then you look inside the interface, you'll see the hello and dead timers in there. The hellos must be identical on each side of the router. Meaning on router 1, link F01, or let's make it even more simpler, on router 1, link F1, on router 2, link F2, they have a crossover cable connected between each other, then that means that those hellos, those timers need to be the same. One cannot be 11 and one cannot be 10, or it will not create a neighbor relationship. OSPF is that picky. Okay, so once it receives a hello, then it's like the other router says, oh, initialization, okay, somebody just woke me up from my nap. All right, cool, what's going on? Oh, router 1 sent me something. Okay, well, hey, let me reply to router 1. Two-way state. He goes, okay, I got router 1, he's awake. All right, so hey, let's begin to exchange link state database information, right? Let's exchange these database information. And that's called the X-start state, exchange start, right? So they start exchanging link state database information, right? So that's why it starts getting, when it starts loading this database information into their own, that's called the loading state. After that, it says, well, do you have any link state requests, all right? But it only does it one at a time. And it says, yeah, I got some link state updates. Let me send you some new networks that I have, and then it'll start sending it. Link state updates, link state updates, link state updates. Because router 1 will say, hey, we're requesting, hey, router 2, you got any, I got your database information, but is there any more information that I would require? LSR, link state request. And he'll say, well, yeah, you know what I do? Let me send you another link state update. I just learned about this new network that I have. And it'll do it one router at a time. Once both routers, again, know about their entire, each router's database, all the networks, then that becomes the full state. That's when you get that little message, and you'll see it. And this happens, in a nanosecond, pretty much, right? When you're configuring and you start doing the neighbor relationships, you're doing router per router per router, you're going to say full loading or loading full, right? When you get to that state, that means I already know about you, you already know about me. We can exchange, we can start changing, we can start sending link state updates as needed because everything is based on triggered updates. But again, OSPF is picky. Now, the requirements. Look at this. This is how picky it is. Interfaces, primary IP address must be in the same subnet. Well, yeah, it has to be. Why would you put 192.1 two routers connected through a crossover cable, and they're on two different subnets? That makes no sense. Okay, so you have to be in the same subnet. Okay, must not be passive on the connected interface. I love this word. I just love it. You mean I have to be up? I can't be down, right? Not up, down, or down, down, right? So I have to be up, meaning everything's up and running. Well, yeah. If it's administratively down, nothing's going to work, all right? If it's down, it's a physical layer issue, all right? If it's up, down, that's a layer 2 issue. You screwed up somewhere, okay? So, yeah, it must not be passive, meaning your interface needs to be working. It must be in the same area. Now, at this point, remember, we're talking about neighbors. Neighbors directly connected to each other, okay? So, okay, we have to be in the same area. That's why everything connects to area 0, then indirectly we can connect to area 0 because that's just the routing process, okay? Hello and dead timers must be the same. Oh, yes. Show IP interface, whatever it is. Let's say it's F01, F02, F03, whatever it is. Okay, show IP OSPF and then the interface, and you'll see the timers. Okay, those timers need to be identical to the person you're connected to the link that you're connected to, your neighbor's link. If not, you're not going to become neighbors. Router ID. What the hell is a router ID? Router ID is the name of the router in an IP address format. And even in IPv6, the router ID is an IPv4 format. And it has to be unique. Router 1 cannot have the same router ID that router 2. Well, think about this. Imagine a classroom and everybody's named Laz. Hey Laz, I want you to answer. Which one? Which Laz? So, okay, so your Laz D, your Laz E, your Laz 3, or your Laz 1, your Laz 2, your Laz 3. So you gotta make them unique. Because if you say, hey Laz, everybody in that classroom is gonna respond, right? So a router ID must be unique and is an IPv4 format. Now, this is an optional. The next one is optional. All right, it's up to you if you want to do any kind of authentication through OSPF. Okay, because every routing protocol has authentication, and you can do authentication within the protocol themselves. Meaning the protocol behind the scene is authenticating to each other. So it must pass neighbor authentication if you configure it. If you don't configure, I mean that's a no-brainer there. If you configure authentication, should it pass? Yeah, it should. It does. It needs to pass. And K values, it's not applicable for OSPF because OSPF doesn't use K values. It can care less. It uses other things, all right, to come up with a cost, okay, in order to do what it needs to do, to find the correct or the best route to get to a destination. It uses cost, and that's all done with its Dijkstra algorithm in combination with the shortest path first algorithm to come up with a cost value. The lower the cost, the faster it is. The higher the cost, the slower it is. You don't want but K values is not something that we use here. K values is something you use in EIGRP. EIGRP is dependent on K values, but not in OSPF. Cool? Now there's different types of authentication. Type 0, no authentication. And this is really for testing purposes. I mean, seriously. Right? When you're configuring an authentication, you can either keep it in plain text or you can do, MD5, or whatever. But there's 3 types, 0, 1, and 2. Again, this is just something for testing purposes. All right, and this will be the configuration that you will actually do. So you go for plain text authentication, you go to the interface, all right, and you type IP OSPF message digest key 1, MD5 Spiderman, all right, and then you can go router OSPF 1, area 0 authentication, message digest, all right. And then router 2, IP OSPF message digest key 1, MD5 Spiderman, IP OSPF, pretty much the same thing. Okay, I think I got it backwards. I think plain text is one on the bottom because we're not using any. We're using the same thing, right? IP OSPF message authentication. We're using authentication. From links. All right, so there's 2 types of authentication. All right, that we can go ahead and use. But again, our authentication is something that is considered optional. They're not going to be able to understand it. The one thing that you need to understand is the requirements to become neighbors, the different states that OSPF goes through to become neighbors, and this terminology right here is extremely important that you understand these acronyms and what they mean and what they are, and of course thinking about all these different things. Now again, we're going to be configuring single area OSPF first, okay, so it's not going to be very difficult, all right, and later on we'll be configuring the designated router and backup designated router, and I'll show you the differences, the different ways that we can make a router a designated router or backup designated router. So we'll speak on that later. But when we start configuring single layer OSPF, it's very simple, very straightforward, not a big deal, but we'll take it a step at a time so you can look at all these things, so you can understand the terminology on the database, the shortest path, the LSUs, the LSAs, the areas, and all that good stuff. Once we configure multiple area OSPF, that's when you can say, oh, so that's what an area border router is. Oh, so that's what inter-area router is. So you understand. But for now, familiarize yourself with the terms and definitely how OSPF becomes neighbors. Be very, very familiar with that, because that's extremely important. All right? Especially when we're going to a multiple area OSPF, because you have 4 billion areas you can create. And just as a side note, if we have 4 billion areas, over 4 billion areas that we can create, are you going to say, hey, John, what area are you in? I'm in area 10,021. Oh, I'm in 15,236. Nobody's going to remember that. So you can turn areas into an IPv4 version format. And that's normally how it's done in the real world. You actually convert the area to an IPv4 address. It's easy to say, well, I'm in area 1, I'm in area 0.0.0.0.0. Well, I'm in area 1, 0.0.0.1, and so forth and so on. Okay? So it's a lot easier to say that, especially when you get into the hundreds or thousands or millions of areas of OSPF. If you have that, then definitely, I mean, in telecom, we used OSPF on the core of the network, which I had no hands on that. I didn't touch that. There was another department that was out in Texas, but we got to see, and at least we can see their routers and go inside and watch. And what you see is where they're using areas, it's based on IPv4 addresses. All right, IPv4 addresses. So that's a reality. So I don't know if they're going to do it for the exam. I doubt that, highly doubt that. It's rough enough as it is for the new 200-301. But this is really important. But once you start doing the configurations, you'll understand what is going on. What is going on with OSPF. But for right now, familiarize yourself with all these different terms and what OSPF creates. Cool? I'll see everybody in the next one.